to start this module by revisiting our major theme for the course on web application architectures and describe where we're going with the whole browser-centric programming in that context. Okay, so I call this Evolution of Web App Architectures Revisited. And so you have to think of, and this is a busy slide, I know, but the main thing is you have to think of the web browser as a runtime engine, right? You write any program, any program that you write, whether you're writing a main program, whether you're writing a component, an event, I mean, whatever software that you're writing, you have to be very aware of the runtime context that it's going to operate in, right? When you start a process, the operating system scaffolds for you a bunch of services available to you. That's why you make operating system level calls, and then you might bring in third-party libraries and so forth. And then you have to think about what's going on at runtime. We talked a lot about that with our web application architecture so far. We've talked a lot about it with Node, right? The whole single process, single thread event queue model. Now we have to think of the browser, right? When you're writing applications, web applications, and you want to use the browser and write code that runs inside the browser, now you have to start thinking about, well, what is the browser's runtime environment that it's presenting to me? What kind of computational model? Is it multi-threaded, single-threaded? What does it do with content that it receives? What's it do with the stylistic information we get from CSS? What does it do with the JavaScript, and when does it execute it, and how do those things play off each other? It's a very unique programming environment, and it's involved, and that's what I'm going to talk a little bit as an overview today, and then we'll jump right into it. So revisiting the evolution of the web. All right, original web servers served documents, so we talked about that, right? It was a document serving platform. And then kind of the document, we started to think of the document as a bit of content fragments, right? You started to see these first pages, and of course I'm going to go back to my scribbling, right? So it used to be, and actually, I guess I'll do it this way. It used to be, your browser hit a server and basically did a get of, docs/foo.html. And foo.html would be self-contained. It would send foo.html back. Foo.html sat out on some doc root of the file system of the server. There would be a docs subdirectory, and in there would be foo.html. And it would grab it and it would send it all down to the browser, and the browser would figure out what to do with that. One hit, one at a time. As we talked about at the beginning of the course, now pages got far more complicated. Now when you hit that server, instead of just getting foo.html may have, when it loads in, a whole bunch of stuff in here that caused additional server requests to go, and maybe to many servers, to go get images, to go get additional content. So we started to think of the document as a container for content fragments, all right, and thought of starting to assemble a page, if you will. At the same time, but in the early days of the web, again, folks started to think, well, what if I wanted to programmatically generate some of that content? I wanted to do some interesting logic. I wanted to make use of existing application logic. All right, so very early on, folks realized, hey, maybe I can run some of my applications, have them generate output, and essentially I'm running a quick way of doing a distributed program. So we talked about the CGI architecture, right? We dynamically generated the content for the CGI, so we had these dynamic behaviors as part of our HTML output, and we talked about the CGIs had to generate the entire page, right? So there are two things about CGIs we talked about several pros and cons. Let me slow down. But two main things we talked about were, number one, spawn a process, right? That's our runtime architecture. We had to spawn a separate process and run this thing. And two is the CGI took over our whole output stream. Right? So if I had HTML that I wanted to output with the dynamic behavior, I actually had the program have to give me that HTML-based content. All right. We talked about the evolution then toward SSIs and server-side scripts, if you recall as well. Remember these guys? Here instead, we went back to the paradigm of having a page where we just wanted to put in little bits of dynamic behavior, page counters, a date timestamp, some little dynamic content It eventually evolved into something more complicated than that, as we talked about. Full-blown server-side scripting languages that could access databases and other legacy applications and the like. From our perspective of these two things, the server-side scripts did no longer serve to spawn to process, but they were computational overhead on the server because now the server had to parse a server-side script and figure out what to do. And then we didn't have to do the entire output, if you will. But at the very least, we started from the perspective of an HTML page, and we had these embedded scriptlets in it. If you remember when we were looking at some of the syntax for this, it was kind of like some of the syntax in our EGS and Jade. A scriptlet might have buried some kind of stuff inside a comment or something like that, and then did some stuff, right? And basically the server side had to parse and know where to look. Was it in a comment? Was it in a special kind of tag, like a % tag or something else? Whatever the server side scripting customization was, it will go through, parse that out, and do these little dynamic pieces of behavior. And I mentioned this again. We talked about implicit invocation and so forth in there as well. But I mention that because effectively through this period, still in the relatively early days of the web, the web was still viewed primarily as a document serving or perhaps content serving platform. And then the web started to evolve more toward an application serving platform. And again, it wasn't some day in time where I could say, hey, on February 1st, 2002, the web officially became an application server platform. No, it evolved in this direction. But more and more folks were talking about how to deliver application functionality and having it more than just be an application serving platform. Now, we still consume an awful lot of content, right? We consume content in our web browsers. We consume them on these mobile devices. We are, now the web through your TV. I mean, we are content consuming society. The way I like to think of it is that the web is now an application serving platform whose killer app, if you will, is content consumption, delivering content. But we start from an application delivery standpoint. And so we can do a number of applications, including ones that are content driven. All right. So as we move toward this dynamicism, is that even a word? This dynamic behavior, understanding as an application serving platform that the browser is now a runtime environment. The browser is more than just a place to go, is not just an intelligent render of markup documents. It's now an application serving platform. It's now a runtime environment. So we have to understand what goes on in that runtime environment. Okay. In that evolution, it's been difficult, but now it has ECMAScript 6, in fact. There is a standard for JavaScript. You can go, I can post some links to, there's a level of browser compatibility on the ECMAScript standard, but all flavors of JavaScript and browsers, all the underlying engines have slightly different variations compared to the official ECMAScript standard. If you notice, by the way, this is ECMA, which is a European standard, not ANSI standard, not International Standards Organization, ISO. It's an ECMA standard. And that's in part the U.S. didn't get all that involved, if you will, because it was too much of a market battle over what the nature of scripting languages would be in the browser in the early days. In IE, they were promoting trying to write their own variations and things like VB script embedded in a browser. But JavaScript is the language of the browser nowadays, but there are still minor variations. I'll post some links as well about where you can read about some of the differences between the browsers and the browser engines. But for the most part, there is this ECMAScript standard out there. Okay, the browser as runtime engine. First, I put out on Blackboard for you Tali Gassari's paper on how a web browser worked, and it basically, and really I want you to emphasize the part about the parsing and the construction of what's called the document object model, or the DOM, which we are going to talk about in short order here. But I'd really like you to read that paper. It's a required reading. You should really read the whole thing because it's very enlightening, but you should at least certainly read through those first 10 pages on it. Does a better job than I could do on explaining what goes on, what the browser does with content, parsing it into the DOM, the order in which it loads things, and even talks about some browser differences, although realize that paper, I believe, was 2011, and the market evolves very rapidly, so some of the stuff that she says about the distinctions between browser engines is now dated. However, I'll have links to other things that summarize some of the differences between modern browsers nowadays and the set of JavaScript engines embedded in different browsers. All right. So again, moving forward and thinking of the web and our as an app delivery platform and browsers as the runtime environment. You have to think of the different kinds of apps that you want to run in that environment. So you may have an e-commerce app or a content management, content consumption type of application. You may have a vertical like education, healthcare, financial services. So just like any other application or system that you would write, there's going to be certain common functional and non-functional requirements for these different what they're called verticals. All right. Healthcare is going to have particular standards related to the security and privacy of information. Education, the same thing. And nowadays, your web code can get audited to make sure that it doesn't release that kind of sensitive information. As a side anecdote, a few years ago, if you remember, maybe I find a link for this as well. If you remember that when healthcare.gov first came out, it was a fiasco, right? It basically busted. It was had very rudimentary performance flaws, but it also had some very serious privacy flaws. It was kind of humorous. At the year after, I was actually teaching a security class, and I found out that one of the people that Kathleen Siblis, in front of a congressional inquiry, a congressional subcommittee, said, "Oh, there were some hackers out there that basically found some rogue things, and we're dealing with them, and we're going to close those holes." Well, it turns out one of the hackers she was referring to was a gentleman who works and lives right near the ASU Polytechnic campus over in the town of Gilbert, just west of us. And he was actually one of the past presidents of the U.S. Software Quality Association, and he wasn't a hacker. He wasn't some rogue hacker or anything. So he came in and gave a guest talk, and it was very scary. It was very enlightening. He basically said he went to healthcare.gov to sign up his foster granddaughter for healthcare services, and the issues that he found was that he found by looking at the source and what was being downloaded and put in the runtime of his browser from the server was like 15 years of unencrypted tax information that he had filed. Just megabytes of stuff, very sensitive and private information that never belongs in the browser in the first place, let alone belongs there in what's called the free and clear. So not a hacker at all, if you will. But I mentioned that going back to this point is there are sensitivity issues you deal with. I do research in mobile healthcare applications, and using web mobile technologies, we have to be very aware of situations where sensitive information could be leaked and make sure that we audit and do the proper processes for those kinds of things. Social media is a big one nowadays, right? Totally different kinds of site, the whole activity feed concept and so forth. So I mention all these things because the nature of the applications you want to build and how richer the functionality is just like any other requirements process you're going to do. They may bring their own domain-specific requirements into the sphere of your application development, and so you have to be somewhat aware, well, not somewhat, or you need to be aware of what those kind of domain requirements are and how they're going to factor into and be compatible with things like your performance and scalability requirements, your security and privacy requirements, and so forth. All right. Okay. Common functional aspects of web applications still render primarily, but not exclusively, through HTML. And nowadays we still have remnants of this click and wait. All right, this notion of we click on a page like we talked about with the what I call page turning issues. Is click on a page, the whole page refreshes, and of course that's still common. Although more and more we're seeing the use of advanced technologies to try and get away from this entire page turning model. All right. Computation, I mentioned as a runtime environment. What do we have to be aware of what the browser provides, its ability to support extensions. Extensions are very popular nowadays. Which rendering engine it's using, and which JavaScript engine. So when you read about the internals of a browser, There will be both a rendering engine and a JavaScript engine that'll be talked about, and they're not the same thing, although clearly they have to talk to each other, right? We're going to talk about how JavaScript can manipulate aspects of the processed markup or aspects of the process style sheets, and what programmatic things that you can do there. All right, so we are going to start in this part of the class by revisiting JavaScript, like we talked about at the beginning of the semester. We're going to talk about in the context of manipulating the content that's inside the browser. Okay, continuing the evolution of web application architecture. Excuse me. As things evolve, folks again went toward application delivery, meaning developers realized you could write full apps in JavaScript. You don't have to do that full page turn. I can now be more responsive to the user by not having to do a round trip to the server for every little thing, right? So if I go, to eliminate this click and wait, what I'm basically talking about is, let me go back over here. Let me go to the next page. What we're talking about now is, I'd load a whole HTML page and I click on a link. I'd go to the server would give me a whole new page, and all of a sudden all that markup would have to be re-rendered, even if the only thing that changed was this little element. All right. Now developers realize that they can manipulate and do some processing around just this element while not having to mess around with or not having to change this whole thing. All right, that's one thing. The second thing is folks also realize that they could prevent any round trip to the server like this if I already knew the information that might change here, right? So let's say that was let's say this is a UI widget to select a state in an address or something like that, right? Well, there's only 50 states. What if I preloaded that list into the JavaScript, put it into the browser, so I had that in the background, if you will, and therefore I could just change that without having to make a round trip to the server, is the point. This creates responsiveness because I have no latency, right? This is user responsiveness. We're going to talk about responsive web design. This is only, well, it's related, but it's not exactly the same thing that the term means. But responsiveness in terms of no latency, because I don't have a round trip to the server, and no page refresh, so I don't have to reload the page, I don't have to reparse it, I don't have to re-render it, I don't have that screen blink that goes on when that happens. My ability to use the information in the content as the backing model for my user interface is where we get into something called a single page, the start of, I should say, a single page application, or what's known as an SPA. All right. Think about how a GUI-driven program. All right, let me go back to here. Think about how a GUI-driven program is written. Actually, let me stay here. You write a graphical user interface desktop program, right? Look at this. Look at this smart notebook I'm in now, right? It's got all these. It's got all these widgets along the top as a palette, right? All this stuff here. And when I do something like I click on a button, right? I click on the left arrow, something happens and the screen redraws. I click on the right arrow, something happens and the screen redraws, right? So each one of these has an event associated with them. And oh, by the way, when I clicked on the left arrow button event, I see all this data reappear on the screen. All right. So there's an information model behind each display, right? This entire inner window bordered in blue around here, right? This whole thing, I'm gonna, the stylus is not gonna want to, I'm talking about this whole thing, right? This is a bit of a canvas in here, okay, which has information on it, right? That has to be stored and represented internally somehow. I mention this because in our application, this is user interface state. There's a notion of state here, right? Anything stored in essence, from this application standpoint, this is world model state. This is the data it knows about, reasons with, and manipulates. Okay, so we have the same thing going on in our web page, except for now our web page. What's the UI state of our web page? Well, it's all the internal markup. It's all the HTML, right, that you can view source on. right? The rendered form of that is what you see in the browser window, but if you view source, you've got a whole bunch of HTML in here. And we already talked about things like a hidden tag, where I can bury information inside that page. It's not even rendered, okay? So there is this notion of this actually becoming more than just a document. It's a document plus UI state. And now I can use JavaScript to listen for and handle events that manipulate that state, right? When I think of it that way, I'm basically writing the same thing as a desktop application program that listens to UI events, just like this smart notebook is. All right. So what we mean by that is by going away from the page turning redraw thing and doing more of that UI logic for responsiveness sake inside of the browser, we're going back to the world of fat clients, as it's called. I don't know how old you are or how if you're familiar with this terminology. So let me summarize what I mean. Another one of Dr. Gary's 30-second overviews of computing. Information processing age, emergence of computers, pre-personal computer. What was the main computing environment? The main computing environment, I can't seem to get away from from drawing this. The main computing environment were really big machines called mainframes. All right, my job as an undergraduate was to program an IBM 30X KX mainframe at my university, and then I went and worked for the New York State Tax Department, where we had mainframes and we had rows and rows, I should draw this in green because they were in green screen, of operators looking at tax information on text-based terminals, big bright green phosphorus, that ran wires, physical wires, no wireless, into an intermediate box called a controller box, which literally had those big thick coax cables, and eventually they ran patch panel up from the 5th floor of the New York State Tax Building to the floor, I don't know where it was, where the mainframes actually sat and reside. In fact, kind of think it's still done that way because they tried to get rid of all this stuff years ago and it never happened. But in any event, my point being is these guys, these terminals, imagine a terminal operator sitting in front of a plain screen with that green screen form. You go into, I was into the auto shop getting my tires done, right? The green screen still comes up. Some places still have these kinds of terminals, as they were called, all right? But the terminals aren't intelligent. There's no real processing or logic going on in the terminal. They're just a connection that talks in a process that's running like many processes on some big back-end mainframe. All right. These are called fat clients. Or I'm sorry, these are called thin clients. They were thin in the sense that they didn't do much of anything other than display, render information, and take input. They were just input-output devices. They didn't do any computational processing. Okay. Well, what happened? Well, our friends at Microsoft came along, and Microsoft wasn't the first one in the world, but the predominant market driver, you'd have to admit, was the Windows platform, right? IBM before that, others before that, but for the most part, the PC revolution was about putting more computational processing, all right, more computation here, on the PC, so you didn't have to put as much in the mainframe. You could distribute processing out to many PCs, all connected internally on your local area network in your company, and then your local area network would have a bridge out to other area networks, and then eventually to the internet when it came about. All right, and in this kind of model, you might have a LAN-based service for a shared file system. You might have a database that's shared. All right, I don't know if you ever heard of things like FoxPro or something like that, but all these things would run on your local area network. And so the PC revolution came about. Windows was, market-wise, Microsoft made sure Windows was on all these boxes. They had business driver software that we're using today. You can see I'm using PowerPoint. To do all these kinds of rich and interesting things. But the fact of the matter is that the fact that I was doing more computation, my actual business logic computation on the workstation instead of on some big mainframe, made this a fat client model. Okay. Now, so far I've talked about, this is the 60s and 70s, this is the 80s, early 90s, and then the internet comes about, right? And the browser comes about. Early days of the internet, in the early days of Java's revolution, let's say late 90s, as we started to realize we could build applications on this thing, there was a guy, Scott McNealy, who was CEO of Sun, who tried to coin the phrase, the network is the computer. He basically was trying to sell folks on the idea that we can go back to a thin client model now, right? Because there were some problems with the fat client model, right? People got tired of having to buy new computers and refresh all their computers, as well as always hire in-house IT staff to go around and fix all the problems that are on PCs all the time. I don't know about you, but I spend a fair amount of my time just doing tech support from all my stuff at home. So the lower maintenance costs, lower device costs is something that Sun tried to sell. Sun actually had, let's see if you can see. I wonder if I can take the camera. Here's what I'm actually drawing on, folks. By the way, you see captured. I don't know if you could see that, right? This is a very thin digitizer tablet. Sun conceptualized taking and having these kind of screens like this, except for they were thin clients, and all they would have is a card reader on the side, and you'd swipe a card and you'd have your entire computing profile on a card you carry around in your wallet. Or at the very first Java 1, they had a Java Ring. I should have brought it down here for this. The Java Ring had a mini virtual machine running in it and stored your entire profile for it. So this notion of now I carry my computing data and even my programs around with me, and all I have to do is plug into a thin client running a Java virtual machine type of thing. Also, as the web, all I need is a web browser, right? All these terminals could have is a web browser that talks to a server, and the big honking server that would be your browser. So iteration number 3 is the browser now goes and talks to big servers over here. Now those servers, they weren't mainframes, but now they were high-powered servers that Sun was selling. IBM they still do, that were optimized for the computational profile of doing server-side driven web pages. All right. So our server-side model, you know how I make a mess of my scribbles. Next evolution was, big. What's called a big iron web server that talked to the world via many little browsers, right? And the browsers, these could all be thin is the point, because all the processing was going to be done on the server of interest. All the browser had to be able to do was to render some markup, okay? Net document serving model, or maybe could run a few applets, but it didn't have to be a high cost machine. It didn't have to be the big thing of the PC revolution and so forth. I'm going back to something that's at least in a thinner model. Okay. Well, welcome to the new age. The point is now as we are moving applications off into the browser's becoming big or fat again, the fat client model, and the server is now becoming, say, cloud-based. I'll use as much server processing on demand as I need. I'll be API driven, which we're going to talk about. And I'll now start doing more of my stuff in the browser again, right? Whether that browser is the workstation I just showed you, my laptop over here, my phone right here, right? These things now have more computational power than PCs did even a decade ago. So now I can start being a fat client again. So I can take, there's a few benefits of that. I mean, why would folks, let me go back to the slide. Why would folks go back to a fat client model? Again, the pros of the fat client model is, first of all, you're creating a market around people wanting to buy more devices, right? An Apple iPhone, $700 some odd dollars, versus a cheap phone that I got at Walmart that's $40 some odd dollars. They're not the same because computationally they're not the same. They don't have the same processor, they don't have the same memory space, they don't have the same rendering capabilities. So now it becomes a consumer choice. Second is I'm distributing processing everywhere. If I make this phone do more of the work, that means the server doesn't have to. And when the server doesn't have to, it means I can go to models like the cloud, and I can go to models where I don't have to buy as much capacity on the server side that I'm not utilizing very well. And I've essentially offloaded a bunch of my costs to my customers as opposed to me paying it, things like that. Now, of course, there's, that's some of the benefits. Let me slow down here. That's some of the benefits. You're alleviating the computational burden on the servers. You're enabling that cloud and mobile computing platform. However, of course, there are cons in this type of fat client model. You can be less secure and less private, like I was just mentioning with healthcare.gov. And it can also be harder to test both functionality wise and performance wise, because of the variation of devices. Certainly I have an Android device. These devices are much different. There's a much richer set of laptops and workstation style computers that there were in a day, so it can be very difficult. And then there's a range of browsers out there on top of that, which is our runtime environment. So my ability just to test across my apps across that are running in the browser across all these platforms, that cost goes up, the complexity of that process goes up. Okay, well, whatever the pro and con, whether whether you believe in a thin client versus or a fat client model, either way, the trend is clearly going toward the app-centric model, toward having clients that can do more, apps that can do more running in the browser. Driving factors, the responsiveness of it, the cost proposition for folks on the server side. It's just the trend where things are going. Okay, so if we look at that trend, what we basically have, if we revisit our model from the beginning of the semester, we have CGIs, SSIs, and server-side scripts. We talked a little bit about, just a little bit about implicit invocation, that notion of server-based handlers inside of Apache, for example, which was more of a, not a programming concept, but a bit more of an architecture concept at runtime. We talked about the servlet component and container model. We talked quite a bit, and you did some Node.js. Those different variations. Well, now we're going to add browser-centric applications. This notion of a single-page application, for now, think of that as the desktop coding model. All right, you will do a single-page application in this class, but then you go to, we still have a need, even in the single page application, to talk to effectively our world model state and other behaviors that may still be on the server. So there's a balance between doing things entirely in the browser and some of the stuff we may need on the server, when we need it, how we get at it, what the clean conceptual model is. So we will do interactive applications where we access the world model state through just a component of a document using something called Ajax. And then we'll talk at the end of this about being full-blown API driven, which means effectively our application is driven by an API that resides on the server, while we still do plenty of local computation for user responsiveness and event handling and things like that. And we're going to revisit the MVP pattern, the MVC pattern, and move towards something called MVP as we do so we kind of understand and have, again, this design pattern based framework for understanding where different responsibility of the system should map to. So all the stuff we talked about in Node, we will revisit that in the context of browser-based application. We're going to start inside the browser and kind of build our way toward that. Okay, so that's kind of what we're doing. Now, again, this isn't a gold standard. This isn't necessarily, this is 20 some odd years of web application evolution that I'm glossing over in the span of one presentation. But in terms of our understanding of how web application architecture styles have evolved over time, I think it's useful enough to think in terms of this style evolution. Nothing was linear. There's tons of literally hundreds of frameworks that have been proposed and developed for web application development. There are certainly some of your own favorites out there if you're a Django person, you're a Ruby person, or whatnot. But largely speaking, I think this evolution gives you an idea of how things have evolved over those couple decades of times and where they're going and how that impacts what we're doing in this class. Okay, so let's make things a little bit more tangible for a second. We want to run applications inside our browser. So what's the first step? So let's switch to something a little bit more concrete. How do you actually get and use a script on a web page? All right. For you to use JavaScript in your rendered HTML response, meaning in your web page, you either have to put it in line in the HTML content, or you have to reference it. Okay, you put it in line well, in either case, you're going to use the script tag. All right, begin, end script. You also have script down here for remote references. You should, now if you don't include the type attribute of text JavaScript, usually your browser will figure out it's JavaScript anyway, or just assume it. However, it's best practice to make sure your type text JavaScript is in there. And then you could just put your JavaScript code in line right there. All right. What's going to happen? That code will directly be invoked as the page loads. It could do things to output HTML content. Well, JavaScript can do all number of things in the browser that we're going to talk about starting next. But you have to be very careful. We are going to talk about the nature of what the browser is doing as it's downloading and rendering content versus firing up its JavaScript engine, because if things happen out of order, your web page can break. Meaning, if you put JavaScript code in here to manipulate HTML, but that HTML hasn't been fully parsed and in a state where you can manipulate it, you'll actually get some problems on your web page. Things aren't going to work the way you want. They could even crash. Okay, so we'll talk about things like that. This approach isn't really the best for doing things like defining functions or doing things where you can do them in external files for two reasons. One is it's less reusable. If you have some common JavaScript code that you want to use across multiple pages, you don't want to cut and paste and put it across each HTML page. You want to put it in a JavaScript file external so you can reuse it. Second is it's typically slower, actually, because you have to parse through all the JavaScript in line with the HTML, and you're kind of competing for resources in a multi-threaded browser against stuff that Garcia will talk about and I'll talk about. Whereas if you have it external, it can be cached, just like HTML content be cached. The browser can maintain its own cache and not have to re-download it or re-download, reparse, re-grab, if you will, that same JavaScript. All right, so you can do things by reference, and it's preferred for things that are functions or other reusable code. You do it by putting the source attribute with this. This just says myscript.js, but this is your relative URL back to the same server. In this case, the my-script.js would be in the same directory, same place that the HTML content was in. Again, we still have the type attribute here. Notice there's no content model for the tag now, because I've basically indicated through this attribute that I'm going to be grabbing something remotely. Purpose for this: go ahead and define those functions, objects, variables, things that are reusable across different pages, and plan on those functions being later triggered by widgets, things like buttons, other user events, inline script tags, and so forth. So actually I have a very, very simple example of this, our loading scripts HTML page. This is in your code directory JavaScript 2 that's out on GitHub. If you notice, we have two examples of a script tag. One is right here, where this is, and this is common. It's inside the head. I go and grab the remote source for the fish.js code, and then down below there is a script tag. All right. That has some embedded. This is basically just a function call. Now you don't see show winnings 2 anywhere in this page, which means that function must be defined inside of fish.js, which sure enough it is down here. Okay. Now secondly, you also may have picked up, let's go back to loading scripts.html, we also have an event handler. So we're going to talk about event handlers very soon. Notice there's no script tag here, but I'm still invoking a JavaScript function. So we're going to talk about the nature of event handlers built onto HTML5 widgets, and the fact that you can then write some JavaScript code inline right here, including this function call, which is the common thing to do, without having to embed it inside of that script tag element. So there's actually another way, more than I just put on the previous page. So show winnings 1 is also inside of fish.js, which means fish.js had to completely download and be parsed and ready to go before anybody would click the button on that page. Again, we're going to talk about that process, and each of those depend on a get message function to output some stuff. Let's actually run this page. Now to run this page properly, well first, that's the event handler stuff. Let me load the other one. So let's load loading scripts, okay? So I go to a page here, all right, and it says, how much did you win? I clicked on the button, and each time I click, if you notice the dollar amount changes. Now notice as well that I also already had something where I invoked a function from the script tag, and I can refresh the page and I get a different value. I get a different value. I get a different value, and I get this being different. Why does that happen? All right. Well, the second one, all right, let's go back to loading scripts.html. The second one happens in line, all right, with the HTML, which means that's going to execute as soon as it's read and processed and parsed. Okay, there isn't any event it's tied to, so it's not going to wait to execute on that. It's going to go ahead and execute it when it sees it. Again, we're going to talk about what happens when these JavaScript functions appear in line versus when content's downloaded and rendered in a little bit in this class. But just realize by the standalone script tag in the body element that there's no extra thing that has to happen. It's going to execute it as soon as it's loaded the page, which is why you see every time I hit reload here, right, the message changes. Not only that, but notice how the message up here went away because I reloaded the entire page. Okay. Now what happens with the button click? Well, in the button click I get a message and I keep changing that value. That's because that only happens in the onClick event handler. Okay. One last thing to point out with this very simple example, but it does show you some things already, is notice when I hit this event handler, notice what part of the string changes. Only the dollar amount's changing, right? I mean, pick up with your eyes. Even though this is all running local, there's no screen flicker. There's no redrawing of the screen, right? When we refresh the screen, right, you saw a little screen flicker there, right? But now when I do this, on this number right here keeps changing without anything else changing. So what's going on there? Well, as foreshadowing of what we're going to do next, what happens here is that the JavaScript in showWinnings1 is saying element.innerHTML get message. What is it doing? We're going to talk about APIs like this where we go and find stuff in the web page by an identifier and then manipulate its state, manipulate the HTML it actually has. So going back to loading scripts, if I go and find this p tag, which fish, and notice how it's empty initially. That's why when I load the page there's nothing in there. But now I'm basically just going to regenerate this message. All right, I'm going to do this message right here each time, and I'm going to insert it into that p tag. All right, because I basically found the ID and I'm manipulating its inner HTML and inserting something in there. Okay, you could do that yourself just manually inside of Firebug. So if I bring up Firebug here, I have a document object that we're going to talk. I'm foreshadowing DOM manipulation. We're going to do the document object refers to the thing that I have loaded and parsed, the HTML page, if you will, and I'm going to get an element by an ID. Since it's an ID, it's unique. It's going to return a singular. The ID that we had was fish. So this is inside my JavaScript console, and I run that, and what do I get back? I get that p tag back, all right, for fish, and then I can go ahead and manipulate it any way I want. Document dot actually let me do it right here, so instead of repeating it, I'll take that inner return value and manipulate its inner HTML to say, blah. All right, now watch this part of the screen right now when I hit run. Right, change it to blah. Okay. All I did was manipulate what was inside that p tag. That p tag is inside of, it's invisible here because there's nothing inside it, but now I change it and I insert my own stuff in here. Very simple way to manipulate the content model of a page. Now we start thinking of the HTML that's been processed and put into a data structure that we're going to call the content model or the document model, and then we can manipulate it. Okay, so that's where we're going next with this stuff. This is a very simple foreshadowing of it, and that's how you put JavaScript in the page, and from there we're going to continue to build on that. Okay, so to wrap, and this is just the code for it and shows you different parts of it. I didn't mention the document.write. Probably should have noticed that. The document.write inserts text in the page at a current location. So that's a kind of another way to manipulate the inner HTML, except for that adds a node to the document model. Again, something that we are going to talk about when we talk about DOM manipulation. Okay. And that's it. Going forward, again, next thing we'll do is start looking at the different APIs for manipulating what's called the document object model, like I just did. That will give us a basis for creating responsive user interfaces. After that, we'll talk about the set of events that you can listen to, like that on-click event, but also events related to the page loading and this race condition I've been implying through this conversation. And then after that, we'll talk about local storage, your ability to store persistent information, which is another thing you do, right? Over here, when I'm going to save for you, I want to save the output of this for you. So I hit my Control S, and I'm going to go up, and I'm going to save the scribbles for JavaScript browser intro file. So what am I doing? I'm writing out to the file system just like you did in Node.js. That gives me my persistent store, my storage that's outside the life cycle of one runtime. Which means if I'm doing that in the browser, I may want to do that as well. I want to leverage the file system. I want to leverage databases. And when I restart my browser, I may want some of that stuff back. So the last thing that we'll talk about from a single page application standpoint is your different options for using storage. And we'll focus on just a couple specific ones in there. And you'll do an application using that. All right, and that'll be what we do kind of for our intro to application programming, single page application programming within the browser. Okay.